All right, so now this will be our first experience working in R. So I wanted to show you an example of working in R to clean up our data. So what I created here is an R script that's going to work with our Major League Baseball game data. What we're going to be doing is we're going to be loading the data. We're going to be filtering what data we want to work with, and we're going to create some calculated fields, and then we're going to output the result to a new CSV file. And R likes to work with CSV files over Excel. It's more of a pure form, so it's a good practice to prepare data as CSV and output that data as CSV. So that's what we're going to be doing in this script. So to begin with, it's a good practice, an expected practice, that you document your code. And that's what you see here is this pound sign, typically we do a pound in a space, indicates that it tells R that ignore this, it's a comment. So what I do at the top of each of my scripts is I put a description of what the script is intended to do. In this case, for our course, I'd like you to put and note the course, the assignment, the author, and the date you created the code. And then I usually put some type of kind of lines in between to separate this from the rest of the code. But every time you put a comment or something that you don't want the R to interpret, you need to do a pound sign before that, or the hashtag sign before that. So the hashtag indicates that it's going to be a comment. And you're also free to have spaces in between. Not all languages allow you to do that, but R does. So what I often do is separate different parts of my code with spaces so that it's visually easier to see. And while R really doesn't care, it certainly matters for you when you go back to re-execute the code, or somebody else has to look at your code. So if, in this course, I'm going to I want to have you establish good practices for writing readable code. And so the comments will be very important, the spacing, as well as, of course, the functionality of the code. So now let's get on to the exercise. So first, what we're going to do is we begin the script by setting the working directory. So what we need to do is tell R where on our local drive are we working. So what I did is I created a project, or a folder called analytics projects, and that's where I work with all my files. So in Windows, under the My Documents folder, I created a folder called Analytics Projects, and then from underneath there, I create another folder for each project that I'm working on. So I have Analytics Projects, and then the CIS 6105, so that's kind of the overall project that I'm doing. And then underneath there, I also created another directory called MLB for Major League Baseball. So this folder MLB is where I'm going to be working from under. So what I'm going to do here then is I want to tell R, we're going to set our working directory to this. So when what I can do is hit Control Enter, and I can execute that. Now R knows where I'm working. Now another way to do that, because you don't always kind of know the proper path structure to use, what you can also do is go under Files and find your files that way. So under Analytics Projects 6105 MLB. So right here's the directory that I want to work in. What I can do then is I can go under More and click Set as Working Directory, and this does the same thing as my R code. But then what I do is I take that command that just was displayed in my console, and I can highlight that, Control C to copy that, and then go up to my code and paste it in there with a Control V. And that's actually what I did when I created this command. So that's a little shortcut, or a little easier way to do that, so that you make sure that you're using the right directory. Because that's important, because that's where the data that it's going to be loading needs to be from, and as well as that's any output is going to be put into that same directory. So it's important to first set your working directory. Now next, what we're doing is we're loading our libraries. So R comes with certain libraries of code, or available functions that you have access to. Now, R is a very popular language, and so there are a lot of public libraries out there that you can load into R to bring in additional functionality. One of the most common libraries, especially with working manipulating data, is called tidyverse, and that's what we're going to load in this next line. So what we first need to be able to do is install tidyverse. Once it's installed, then we can load it into our R environment. So right here we have this command is going to take load the library tidyverse, which is going to be our common data wrangling functions, and that will load that into our environment. Now, to execute this, what I simply need to do is have my cursor on that line, hold down the control key, and then hit enter. And so what R is going to do now, and it takes a little bit here, is it's loading this library, which includes a bunch of packages, code packages, which these are all additional sets of functionality, and these are very common sets of functionality. So tidyverse is a very commonly used library in R. All right, so now we have our environment set. We established our working directory. We loaded our library. Now what we need to do is take data from our CSV file and load that into R. What we're going to do is we're going to create a data frame that we're going to load this data from a file into our R environment. And that's what this command is going to do. So what it's going to do is it's going to use the read CSV command. So that means it knows it's going to be reading a CSV file. It's going to load that into the data frame, which is a two-dimensional data structure called game data. We're going to call it game data. We're going to load CSV into that. This is the name of the file that we're going to be loading. And then there's a comma. In this case, what we want to do is in using tidyverse, I can use this read underscore CSV command, and that allows me to use this progress equals show progress. So for larger files, it's nice because on my console, it's going to show me the progress that it's making as it loads the command, loads the file. If I have very large files, R is just going to look like it's sitting there, and I'm not sure if it's working or not. So this progress equals show progress really helps me visualize, or I can look at my console to see, yes, it is working and it is loading. So we're going to try this. So it's going to go out to my working directory, MLB, and it's going to find the gamelog.csv file, and we can show that it's there. So we're looking for gamelog.csv file. So it's going to load this 7.8 megabyte file, and put that into a data frame. All right, so Control Enter, and you can see. So this was small enough where this was pretty instantaneous. It really didn't take long, so that show progress wasn't needed as in this instance. It's still a good habit to get into, so we can, especially working again with larger files, we can see the progress being made. But up here in our global environment, we see that the data frame was created, and the data frame was created with 70,182 observations. So in our spreadsheet in the previous unit, we noticed that we had the same number of rows of data, 70,182, which is good. That means all the data loaded. Now, the language that we use in R in our data frames is each row is represented as an observation. So it's an observation of data. So we have 70,182 observations, and in Excel we had 37 columns. Here we're calling each of those columns a variable, which actually that's what it is. When we're working with the data, each of those are different variables that we could work with. So we have our game data frame. Looks like it loaded properly because we have the same number of observations that we had expected and the same number of variables as we expected. So that command was successful. Now what we can actually do is see the data. So if we click on this blue symbol, it's going to expand, and we can see each of the columns. That's one way to look at that. I'm going to collapse that again. Now another thing we can do is either double click here or click on this matrix symbol over here, and that's going to load the data over here in our file window. And so now we have much more of like a spreadsheet type of view where we can see each of the variables and each of the observations, and we can scroll through there and see that all the way along there. So now we can see our data, and this is really helpful to be able to see the data as you're manipulating it. So we can, as we make changes to it, we can open up the data frame again to take a look at what the changes look like. And we're going to do that frequently in this example. All right, so now next step we're going to do is we're going to remove some unused columns, or columns that we aren't going to use as part of this analysis. And again, this is more for the exercise than actual necessity. So in the Excel videos, I removed the visit doubles, visit triples, and home doubles and home triples columns. So we're going to do the same thing here. So if I take a look at my data set, we can see that those fields exist. So visit doubles, visit triples, they exist, right? So what we're going to do is we're going to be removing those two columns. Actually 4 columns. So what we're going to do though is we're going to take our existing data frame, which has 37 variables, and we want to remove 4 of those variables. So what we're going to do is we're going to end up using the subset command, saying that we're going to take our data frame and we're going to just grab a subset of that data and assign it to the data frame of the same name. Now, if I wanted to create a new data frame, I would come up with a different name here. But in this case, I'm just going to reuse the same data frame, so I don't have to create additional structures and take up more memory and more complexity. So I'm just going to take a subset of that data. I'm going to do that by using the select equals command. And this -c indicates that we're going to take all the data but subtract the following columns. C represents columns. So -c. So what we're going to do, and then in parentheses, we're identifying the 4 fields. Now here I didn't have enough space to be able to visually see the entire command. So what I did is I needed to go to the next command, and I can do that. It's a good practice to wait till you get the comma and then go down to the next line. So you actually just hit enter on your keyboard, and that will bring you down, and it's going to properly indent that as well. So we're going to remove the visit doubles, visit triples, home doubles, and home triples, and then that has to be kind of cased within the parentheses. And then I have a parentheses for the subset command, and this I can see my closing parentheses here. So now when I execute this, Control Enter, you can see down here it executed. It didn't get any errors or warning messages. Up here I can see the 37 minus 4, so I'm down to 33 variables, so it looks like it worked. And now I can actually go and inspect the data and look over here, and RBIs, I was expecting to see the doubles and triples right here. So I don't see that right here, so I did remove those fields. So that command worked. Next, what I want to do is I'm going to rename a field. So if take a look at the data here. So this field right here, the second field in, it's called game year. Really, that's my season. So I'm going to rename, I want to rename this from game year to season. So what I'm going to do is I'm using the call names. So I'm referring to the column names, and I'm going to, of the data frame game data, I'm going to go to the second column and I'm going to rename that. So this word season is going to be placed into the second column as a column name. So when I execute that, Control Enter. Again, no errors, no warnings. I'm going to open this up again, and I can see now my second column is labeled as season. So I just changed my column name. Okay, so now I want to do another form of subset. So rather than looking at only specific columns or removing columns as I did before, I want to remove some observations. So let's say that I want to look at only game data. So remember, our game data right now is from 1990 all the way through 2019. So let's say I wanted to only look at data that's from the current millennium. So from season the 2000 season all the way up to 2020, but let's not include 2020. So what we can do is we're going to update the data frame. We're going to make some changes to the data frame and write over our existing data frame. So we're going to use the game data frame, and what we want to do is So we're using this bracket to indicate that we want to make a subset or a selection of data. So with that bracket, we're saying we want to include only the observations where the season field of our game data frame is greater than or equal to the year 2000, and that season field is not equal to this, that exclamation point is equal, it means not equal to 2020. So that means it's going to filter out everything that does not meet this criteria. So any observations that are before year 2000 or that are 2020 will be removed, and I should see my number of observations decreased, maybe close by half. So when I hit Control Enter with that line selected, I can see that my number of observations dramatically decreased, and we still have our 33 variables. All right, so next what I want to do is I want to update a field. So right now this winner field, or the winner variable, we can see that the winner is home or visit, but let's say we want to ensure that, actually what we're going to do is we want to change that to lowercase. So right now it's all uppercase. Let's just say we want to change that to lowercase. So we're going to update in the winner column or the winner variable in our game data frame, and we're going to update that to the we're going to take the existing value and move that to lowercase. So to lower is the command that we use, and this is the field that we want to convert to. So when I Control Enter there, I can take a look at my data again and see, scroll over a little bit, our winner is now all lowercase. All right, let's change that back though. So let's change that back to upper. Okay, we're just going to now we're going to remove that back, so it's back all to uppercase. Control Enter, and now when I take a look at my data, scroll over, and our winner is now all uppercase. All right, so now we see how we can convert it to lowercase or to uppercase. So that's an example of changing the data rather than filtering data. Okay, now what we're going to do is we're going to filter our data again. So let's say we wanted to look at only observations with a home win, where the winning team was the home team. So what we're going to do is we're going to update our data frame. We're going to take our game data frame, and we're going to only keep those observations where or which that the game data, the winner column, is equal to home. So in this case, the is equal to is we're going to have two equal signs. And then this is a text field, so we're going to be putting that in quotes. And we need a comma after that in order for this to work. So again, we're filtering, so that's in brackets. So as you can see, this command is going to remove all observations where this is not true. So what we should see is only observations or only games where the home team won. So Control Enter. And this is not something we'd really want to do, but we're just practicing with the data. And we saw that the game data went down pretty close to half. And so let's go ahead and open that up. And what we can do is we will see our winner will always be the home team. So I'll load that. There we go. So we removed all the games where the visiting team won. All right, so now what we're going to do is we're going to create some calculated fields. So we're going to create a new field called score diff, and this is similar to what we did in Excel. We're going to create this in our data frame. So this is a brand new field that we're creating, and we're going to say that that's going to be equal to. So what we're going to do is we're going to take our home score and subtract the visitor score, and that value is going to be returned to the new field score diff. So when we hit Control Enter, and actually, so it's not just going to do it to one value, it's going to do it to all the values. You can see we have one more variable now, and what R does is it moves it all the way to the end. So here's our score diff. So a score diff of 2, 2, 1. So let's take a look at this. 2, 2, 1. So the home team, just double check our calculation. So 2 minus 0 is 2, 6 minus 4 is 2, and 2 minus 1 is 1. So it calculated that correctly. All right, so the next command that we want to do is we want to calculate game hours. So our existing data has number of minutes, but let's say we wanted to really also see that data in hours. So what we're going to do is we're going to take our existing game minutes, divide it by 60, and that result will be then returned to the new game hours column, or game hours variable. So when we control enter that, we're going to see that we have one more variable. We're up to 35 variables now, and scroll all the way to the end, and we can see game hours. But game hours is, it's showing it with too many decimal places. Let's say I only want to see this as a 2 decimal number, or 2 decimal places. So what I'm going to do now is I'm going to take that new field that we created, game hours, and we're going to round that, and we're going to round that to 2 digits. So when we go control enter, open this up again, scroll all the way to the end, and now we can see the game hours is now all the way out to 2 decimal places, like we had expected. All right, so now we made changes to the data, and now let's output this data. So what we're going to do is we're going to create a new CSV file, and we're going to take our data frame called game data, and we're going to output that to a file called exercise2.csv. So it's a CSV file that we're creating, and that's correct because that's the command we're using. And row names equals false. By default, what R would do is it would create a new variable, and that would be the row number. So the first observation would have a 1, second observation would have a 2, and we really don't need that. So what I'm going to do is I'm going to set that to false, so that R doesn't create that additional column or that additional variable. So I'm going to go ahead and control enter, and the command executed, and then what we see here is we have the exercise2.csv file, and we can see exercise2.csv file was created. So we created a new CSV file that we can now load into a new R script, and that data will be all set to work with the data as we had intended. So again, this script that we created here was intended to work with the data where we filtered columns, we filtered observations, we added some calculated fields, we renamed fields, we manipulated fields. So we can see a lot of the different things that you can do. These are just small examples of what you can do. But hopefully this gives you a good idea of some data cleaning or data wrangling that you can do with your data to get it prepared for analysis.